Hello, this is part F of the Chapter 7 lesson. In this lesson we're going to talk about our sixth type of hypothesis test. This test is going to look very similar to the two-sample t-test, but instead of comparing population means, we're going to compare population proportions. Things are going to be set up in very much the same way as the two-sample t-test. We're going to have two parameters. Our data are going to come from two independent samples. But the biggest difference, fundamental difference, is that we are comparing population means rather than proportions. So we're going to do just one example in this lesson, and this is example 712 from the textbook. The question that we're going to ask is there a difference in prevalent cardiovascular disease between smokers and non-smokers? Now, prevalence is something that we talked about back in Chapter 3. Prevalence is just kind of another word for proportion. And so a different way of stating this question is there a difference between the proportion of smokers with cardiovascular disease and the proportion of non-smokers with cardiovascular disease? Now, it might seem obvious that the question is yes, and so that's going to be our claim or research hypothesis, that there is a difference. And so let's make some observations here. First of all, that we have two independent populations. We have all smokers and all non-smokers. And we are comparing proportions from these two populations. We want to compare the proportion of smokers with cardiovascular disease to the proportion of non-smokers with cardiovascular disease. And we're claiming that these two population proportions are not equal. So we're going to define two parameters, P1 and P2. These parameters are P because these are proportions. P1 is the proportion of all smokers with cardiovascular disease, and P2 is the proportion of all non-smokers with cardiovascular disease. So our hypotheses are the null. As always, that the null hypothesis is the statement of no difference or no change. And so if there is no difference between these two populations, then P1 is going to equal P2. And the alternative is the same as our claim, that there is a difference, so P1 is not equal to P2. Now, we're not claiming necessarily that one is bigger than the other. We're just claiming that they are not equal to each other. Now, in order to determine with 100% certainty if our claim is true or false, we'd have to go out and survey every single smoker and every single non-smoker, count the number who have cardiovascular disease in each population, calculate the exact values of the population proportions, and compare them. Now, that's impossible. As always, we're never going to be able to determine with 100% certainty if our claim is true or false. So we go out and we survey 744 smokers and 3,055 non-smokers. We find that 81 of those smokers have cardiovascular disease and 298 of the non-smokers have cardiovascular disease. And so just looking at this data, it's kind of hard to tell if the data appear to support the claim or not. But let's just jump into our test here. So the test that we're doing is called the two-proportion z-test. Two-proportion because our data come from two independent samples, and a z-test because our test statistic is going to be a z-score. As always, the book describes the basics of the theory behind this type of test. We're not going to get into that. We're just going to focus on understanding what it is we're doing, what it all means, and then how to do it in Excel. So this type of test is not built into Excel, and so we're going to use some formulas that I built. And specifically, the worksheet is called the difference of proportions. And so here in the yellow cells, we're going to enter our sample data, N1 and X1. So this is the size of my first sample and the number of successes in my first sample. Size of my second sample, the number of successes in my second sample. In this case, a success is a person with cardiovascular disease. It sounds kind of funny to call that a success, but remember that a success is a generic term meaning that we observed whatever it is we're interested in. Here we enter the number of tails. In this case, our alternative hypothesis is that P1 is not equal to P2, And so this is a two-tailed test. And down here we calculate this number that we call p hat, which is described a little bit more in the textbook. Here's our test statistic, 0.92. This is a z-score. And then here's our p-value, 0.3553. Now we're going to interpret that p-value in the same way as every other p-value. Compare that to alpha, which is 0.05. In this case, the p-value is much greater than 0.05, and so we do not reject the null hypothesis. And so remember, the null hypothesis is the statement of no difference between these two populations in terms of their proportions. And so we would interpret this by saying that there is not a statistically significant difference in prevalent cardiovascular disease between smokers and non-smokers. So in other words, our data do not support the claim of a difference. There just doesn't appear to be much difference. That may seem a little bit surprising, but that's what the data tells us. So again, the test that we're using here is called the two-proportion z-test. The purpose of this test is to test a claim comparing proportions from two independent populations. Again, we need independent populations, meaning what happens to one population has no effect on the other population. In this case, our two populations are smokers and non-smokers. It seems reasonable to assume that what happens to one population has no effect on the other, and so we have independent populations. Requirements for this type of test are both samples are random and independent of each other. Again, we always have this requirement of randomness, and we have a requirement of independence in this case. Number two, in both samples, the conditions for a binomial distribution are satisfied. This is a requirement because the binomial distribution forms the theoretical foundation for this type of test. And then the third requirement, and this is stated a little bit different than the way it is in the book. This is a little bit simpler way of stating it, but a requirement is that in both samples there are at least 5 successes and 5 failures. And so that means in both samples we need at least 5 people with cardiovascular disease and 5 people without cardiovascular disease. And that condition is certainly met in this case.